difficulties, and I know a few of you guys are going to be on a field trip, so I made a video. So let's get started. So the first 15 minutes you're going to work on Alex. I'm going to be here, but some people are going to be absent. So make sure you get your 15 minutes of Alex done because we are using that as a grade. So this is just our outlook for the week. Today is Wednesday, obviously. So we're doing quadratic transformations today. We're going to review on Friday, and then you'll have a test on Tuesday. Okay, and then after that, we're going to go to key features of exponentials. So we kind of already talked about quadratic transformations just like in detail, but we're going to kind of go over it again and show you what it looks like. Desmos is going to be very important for this lesson, so just make sure you are having Desmos close and near and close access. So horizontal stretch and compression. This is all about memorization, okay? And I do want to say that this is not a very heavily tested subject. So don't freak out if you don't get it. It is important that you know what to look for, but it's all about memorization. So to determine the effects of horizontal vertical quadratic transformation. So let's just get into the lesson. Okay, this is what you're going to put on your thing. I'm sorry, my little wee video thing's out the way. I'll move it. 72, 73, 322, 323 quadratic transformations. Describe how to change a quadratic equation from a horizontal and a vertical transformation. Okay, that's today's essential question. So a horizontal stretch and a horizontal compression. If the number is a fraction or closer to 0, it's going to be a horizontal stretch. And if it's more of a whole number or greater than 1, it's going to be a compression. So if you see, if it's in between 0 and 1, it's going to be a horizontal stretch. It's going to get fatter. If it is greater than 1, it's going to be a compression. It's going to get steeper. Okay, so those are some of the things that you know. So this is going to be a horizontal compression here because b is greater than 1. So if we have x2 and then we have 8x2, it is going to be a compression. So this is something you can also graph as well. Okay, so a horizontal compression by a scale factor of 8, kind of like transformations last year, but not really, but kind of. This one's going to be compression because this number is in between 0 and 1. So between 0 and 1, we can put the two components in there, and then you'll see it's getting fatter. It's going to be getting compression. If you need to know how to make the dotted lines, I could show you so that you could see that. All right, and I'll just come around, walk around, help. Horizontal stretch by a scale factor of 1/5. All right, now this one is a reflection because it's negative. So we have negative, and we're going to put the negative in there, and you're going to see it's going to be a horizontal reflection. So I think this picture is wrong. I'm going to put it in Desmos real quick. So I'm going to go to Desmos, ignore that because that was an epic fail. I was trying to fix because the copy machine is broken. So that's why I'm going through all these links. And there's a lot of field trips. So I want to make sure everybody had this lesson. So it was, what was it? It's x squared, then it's negative x squared. Okay. I'm going to go to x squared. And then we're going to put negative x squared. So it should have been upside down. Okay. If it's negative, it's going down. So, it's a sad face. If it's negative, it's going to make like a sad frown. If it's positive, it's going to make a happy face. That's the only way I can describe it. But if it's negative, it's going to be a reflection. So that's why this picture is wrong, but it's okay. We all make mistakes. Okay. So when in doubt, put it in Desmos. Or your TI-84 could have done it for you. It's just not as fun. I don't know. I don't think. All right. This one's going to be a horizontal shift. So remember I was doing the parenthesis dance when I went side to side. So if inside the parentheses, you're going to do a horizontal shift. And because it's a minus 9, it's actually going to be adding 9 spaces to the right. So when you do your thing, you see it's going to be going 9 spaces to the right. Okay, horizontal translation, 9 spaces to the right. This one is going to be a horizontal shift, and it's going to go 1 space to the left. So if you go here, less than 0, 1 space to the left. Horizontal translation, 1 space to the left. All right, so we have a vertical compression, which is a parabola. Okay, moves away from the x-axis. Then we have a parabola move towards the x-axis. So it's a compression. So we have a stretch and a compression, very similar to horizontal. We're just going to be looking for 2 different things, and I'll show you what they look like. These are going to be outside of the parentheses. Okay, so these are things that are outside the parentheses. Okay, so like this. This one is actually going to be a horizontal stretch. What, vertical stretch? What was it? Vertical stretch, yes. Same thing as a horizontal, whatever. All right, so it's getting skinnier because scale factor is greater than 1. So vertical stretch scale factor is greater than, scale factor is 2, so it's going to be getting skinnier. And if it's in between 0 and 1, it's going to be getting fatter. It's going to be a vertical compression. Okay. So vertical stretch and horizontal compression are the same thing. Okay. A vertical compression and a horizontal stretch are also going to be doing the same type of actions. So that's what I was going to be showing. Those are the similar things. Now this one's going to be reflection because it's being flipped this way. So yeah, so this one's going to be a little bit different than the one I did previously. Let me go back up to that to make myself clear. Because this is a horizontal reflection, there really is going to be no difference. It is going to be overlapping because it's a horizontal, okay? So it's going to be over the y-axis. So it's not going to really change that much. Now, if it was shifted 9 spaces to the left and then it was a reflection as well, it would be on the opposite side. It would be on the right side. It's 9 spaces to the right, okay? So I just want to clear that up. I apologize. Okay, let's go back to where it was. Okay, if you have any questions, please wave me down. Or talk to me after class if you're not here. Okay, so this is going to be reflection across, across the x-axis because it's vertical. So it's going to be across the x-axis. So a vertical reflection is across the x-axis. So this is all about memorization. And then when in doubt, you can type this in the decimals. All right, so here we're going to be doing the transformations up and down the y-axis, and it's just going to be like it is. If it's plus 2, it's going to go up 2 spaces. Okay. And if it's minus 3, it's going to go down 3 spaces. Okay. So that was today's lesson. You guys are going to work on the practice problems, and then you guys are going to work on the task cards. I'm trying to figure out how to print the answer sheets. If I cannot figure it out, you guys are going to try your best to type them on the slides that I provided. Okay? You will have 40 minutes, and that will be your assignment today. Even if you are not here, you are still responsible for this assignment. All right? See you guys later, or see you in class. Bye.